Welcome to Ab Initio Insider. Today's topic is Ab Initio Parallelism. Ab Initio is a powerful data integration and ETL software that provides a high degree of parallelism to handle large volumes of data efficiently. Parallelism is an essential feature of Ab Initio. It enables to process large amounts of data quickly and efficiently. The software provides three types of parallelism: data, component, and pipeline parallelism. Data parallelism involves distributing the workload of a job across multiple processes. In Ab Initio, data parallelism is achieved through the use of partitioning. Data is partitioned into smaller subsets that can be processed in parallel. Each subset is processed by a separate process and the results are merged together. This approach enables Ab Initio to scale to handle large datasets. Assume we have a large file with 100 million records that we need to sort in ascending order based on a particular field. Instead of sorting the entire file on a single processing unit, we can use the data parallelism to sort the file in parallel across multiple processing units. We can divide the file into 10 partitions of 10 million records each and sort each partition in parallel using 10 processing units. Once each partition is sorted, we can merge the sorted partitions together to produce the final sorted file. Component parallelism is a parallel processing technique that involves dividing a complex task into multiple components, each of which can be processed in parallel. Each component operates independently on a subset of the data and produces its own output, which is combined with the output of other components to produce the final result. Consider a data processing system that involves 5 components. Component 1 reads data from a file. Component 2 filters the data. Component 3 sorts the data, and component 4 aggregates the data. Finally, the component 5 stores the data in a database. So by dividing the task into multiple components and processing each component in parallel, the overall processing time can be significantly reduced. Pipeline parallelism involves dividing a job into multiple stages or steps and processing each stage in parallel. Each stage operates on a subset of the data and passes the result to the next stage. In Ab Initio, this can be achieved by creating a job that consists of multiple components connected in a pipeline. This approach enables Ab Initio to achieve high throughput by overlapping the processing of different stages. Pipeline parallelism is particularly useful for complex jobs that involves multiple processing steps. For example, we have a file with 1 million records that we need to process in multiple stages. The first stage involves filtering the data based on certain criteria. The second stage involves transforming the data into different format, and third stage involves writing the transformed data into a file. So we can create a job with 3 components connected in a pipeline to perform these stages in parallel. Each stage will process a subset of the data and pass the result to the next stage. This diagram shows this approach. In conclusion, Ab Initio is a popular option for large-scale data integration and ETL projects in sectors like finance, healthcare, and telecommunication because of its parallel processing capabilities. In today's data-driven world, where organizations are dealing with growing amounts of data, the software's capacity to handle large volumes of data effectively and concurrently is crucial. So that's it for today. See you again with the next informative video. Please comment with your valuable input. Also let me know which topic you want to cover next. Jai Bharat!